let's learn how to solve rational proportions. Guess what? This is our last math video of the year. We did it. Congratulations, we made it. Nice work. On our agenda for today, I'm just going to talk about the difference between an expression and an equation. We'll talk about how to solve proportions. We'll do some examples together, and you have to remember to check your answers. So let's get ready. You need a notebook and a pencil and your calculator. And here we have the first one in blue is an expression. The second one is an equation. What do you notice? Well, first, hopefully you notice the equal sign. So this is the equation. It has an equal sign. It can be solved. We'll have to think about checking our work, because if I look at my denominator, I don't want to have that equal 0. So that means that x cannot be -9. So if I were to go ahead and solve that, I want to check my answer to make sure x is not 9. In the blue, this is what we have been working on. These are expressions. So we keep the denominator. We get a common denominator and we keep the denominator, and our answer is a fraction. And the second one and the green one, we can get x to equal anything. So with the blue one, you keep the denominator. With the green one, we're going to learn that we're going to undo the denominator in order to solve it. Another piece that we want to compare is here we have two equations. So if you notice in the first one, we have a fraction equaling a fraction. But in the second one, I have a fraction minus some number equaling another fraction. So this one is going to be solved. It's going to take a little bit more work, but they're both going to involve undoing the denominator. So let's take a look. These are the three problems we're going to look at. So the first one is a fraction equaling a fraction. The green one is just a bigger fraction with our two denominators. You can see they both have x's. And then if you look at the yellow one, we're going to notice what's going to happen when I multiply by x. This is actually going to go to an x squared. So we'll end up involving a quadratic, and then we're going to have to factor. So let's take these one at a time. That's just thinking about the denominator. All right, so here I have this, and we're trying to solve for x. So right now, x is being divided by 46, so I'm going to multiply both sides by 46. So when I have 46 over 1, those are going to simplify to 1. And I have x equals 2 times 46, which goes in the numerator, over 23. That's a multiply sign. And so then you just do 2 times 46 on your calculator, divide by 23, and you get 4. That's our answer. We technically don't have any x's in the denominator, so it won't make the denominator 0. Here we have a little bit more in our denominator. We do have an x in our denominator. I'm trying to get to the x, so we'll figure that out. But before I even start, I want to just think about this denominator, and I want to set that equal to 0. Let's see what would make that equal 0. So if I subtract 3 from both sides, get -3, divide by 3, I get -1. So I know that I do not want to get an answer of -1. So I'm going to keep that in mind on my check. And then with the x plus 5, we do have to consider that one as well. Set that equal to 0. Subtract 5. I do not want x to be -5 because that would make that 0. So let's think about what we're going to do. I have 4 divided by this denominator. I'm going to multiply everything by that numerator. Well, denominator that becomes a numerator. So when I do it on the left, it simplifies to 1 and I get 4. On the right, I have 7 times my 3x plus 3 all over x plus 5. And I still have an x plus 5 in the denominator. So I'm going to now multiply everything by that x plus 5. So on the right-hand side, I like to put my 4 first. So I have 4 times x plus 5. My x plus 5's on the top and the bottom simplify to 1. And then I get 7 over 3x times 3x plus 3. Now it's a distributive property on both sides, so I get 4x plus 20 equals 21x plus 20. I'm just going to rewrite it over here, running out of space. Oops, that's a 21. Didn't think those canceled. And then I'm going to subtract the 4x from both sides. Get 17x. I'm going to subtract the 21. Oh, wait. Oh, yeah, that's right. Yep, -1 equals 17 over x. And then I get x to be negative 1/17. And there we go. That answer is not negative 1 and it's not negative 5, so it does check. We just want to make sure it doesn't make our denominator equal 0. And on this one, I have x's in my denominator, I also have x in my numerator. I'm going to start by multiplying everything by this first denominator. So we're going to multiply by x minus 6. Those will simplify to 1 and I get x minus 5. I have to multiply it on the other side, so it goes into the numerator all over x. I still have a denominator, so I want to multiply both sides by that denominator. That's going to be a distributive here, and now you'll see that it does become quadratic. So we get x squared minus 5x equals, I'm going to distribute the 2, so we get 2x minus 12. It's a quadratic, so I want to put it in standard form, combining like terms. So I'm going to subtract the 2x over to get negative 7x, and I'm going to add the 12. And now we're ready to factor. So I want to think of two numbers that multiply to 12 and add to negative 7. It's going to be negative 3 and negative 4. And then I get x minus 3, x minus 4 equals 0. Set each of those equal to 0 using the zero product property, and we get x minus 3 to be 0, x minus 4 to be 0. So x could be 3, x could be 4. Those are my possible answers. If I check back here, x cannot be 6 and x cannot be 0, so that all works out, and our answers here are 3 and 4. So when you're solving proportions, you want to multiply to undo the denominator. If it's quadratic, you may have to factor, and check to make sure that it does not make your denominator equal 0. You get a red star for completing all of my videos and a check mark. Congratulations, we did it.